Hi everybody. So this time around we're going to take a look at a system of inequalities, a system of three equations with three unknowns. When you do these kinds of problems, the first thing you want to do, so there's a goal you want to make for here, okay? You want to get two equations with the same two unknowns. Okay, two equations with the same two unknowns. So you're going to work your way down to either having two equations that have x and y in them, two equations that have x and z in them, or two equations that have y and z in them. Okay, if you end up with one equation that has x and z in it, another equation that has x and y in it, then you've kind of dug yourself into a corner that's really almost impossible to get out of, and it's frustrating. So I'm going to erase this comment because I need the board space. In fact, I hope I have enough room to do this problem on this board. When you get to these problems on your homework, it will take a lot of paper and a lot of time, so just be forewarned, okay? Alright, let's take a look at this. So I've got x plus y minus z equals negative 1, negative 4x minus y plus 2z equals negative 7, 2x minus 2y minus 5z equals 7. So what I need to figure out is which variable is going to be the easiest to get rid of. So hopefully you're looking at this and you're thinking the variable y. So you would be right if you assume that. In fact, if I took equation A and equation B and I added them together, it's going to work out really nice. So x plus y minus z equals negative 1, and right underneath that, so I'm going to use the elimination approach as I do this. It works really well, I think, for when it comes to solving a system of three equations with three unknowns. So you add these two equations, A and B, your x term becomes x minus 4x, that's going to be a negative 3x. The y drops out, see, you've got y minus y, that drops out, that's kind of nice. Negative z plus 2z, that's a plus z. Negative 1 plus a negative 7, that's going to be a negative 8. Now I'm going to go ahead and, for purposes of illustration, I'm going to call that equation D, okay? Now, let's take a look at equation C. I have yet to get equation C introduced into the ballgame here. I need to get it introduced at this point. How I do that? Well, I can use equation A or B along with C, but I have to use one of the two. And I have to involve equation C because I haven't used it yet. So, take a look at equation D as well. I've got an equation with x and z in it, so whatever I do with equation C, that y right there has to go bye-bye, okay? Not x, not z, y. Alright, so if I take a look at this negative 2y here, I think the easiest thing to do is going to be to combine it with equation A. If I doubled equation A, I would get a positive 2y there, right? So that when I add the equation A with C, my 2y here added to my negative 2y here would subtract out, or it would neutralize the y. It'd get rid of it, basically. Okay, so let's do that. So we're going to double equation A, and I'll add that to equation C. Alright, so we'll double this. So it'll be 2x plus 2y minus 2z equals negative 2, right? So I'm multiplying it to all the way through that equation 1, or equation A there. And then I'll just write equation C as is, 2x minus 2y minus 5z equals 7. There. So now I can just add the two equations straight down. 2x and 2x is 4x. My y drops out, that's what I wanted to happen. Negative 2z minus 5z is a negative 7z. Negative 2 plus 7 is 5. And for purposes of illustration, I'll call that equation E. So now we're looking at equations D and E. Let's take a look at them and figure out, well, which one of these is going to be the easiest one to get rid of in terms of variable, the x or the z. Hopefully it's obvious to you that z is going to be the one that needs to go. Now, if you're taking my Math 1010 class, just so you know, on your exams, including the final, they're probably going to ask for a solve for z, or a solve for y, or solve for x. All right, they're not going to say solve the thing and come up with x, y, and z. When you see that, try to make it your end goal to find that variable and not get rid of it due to elimination or the addition method or substitution. Okay, you can, but then you'll have to back substitute to figure out what those values are. So in this case, if I was trying to find z, I probably would have tried to get rid of x at this point instead of z. But since I'm going to try to find all three variables, x, y, and z, let's go ahead and get rid of the z because I think it's going to be easier to do that at this point. So if I multiplied equation d by 7, I would get a 7z there, right? And that's a negative 7z. Good, so let's do that. I'll take 7d plus e. So this equation d, I'm going to multiply everything through by a 7. So I got negative 21x plus 7z equals negative 56. Equation e, I've got 4x minus 7z equals 5. Let's go ahead and add this together. It works out kind of nice. I've got negative 17x equaling a negative 51. And if I divide both sides by a negative 17, lo and behold, x will equal 3. So now that we've got x, we can back substitute. I would probably go after equation d. Remember, equation d is the negative 3x plus z equals negative 8. But I know what x is. It's 3. So negative 3 times that 3 that I just found plus z equals negative 8. So that'll be negative 9 plus z equals negative 8. Add that 9 to both sides. There's z. It's going to be a 1. So I've got x, I've got z. Let's go find a. I'd recommend using equation, I've got x, I've got z. Let's find y. Let's find y. I've got equation a at my disposal that I think is the easiest one to use. So we've got the equation x plus y minus z equals negative 1. We know what x is, it's 3. Plus the y, that's what we're after. Minus the z, which is 1. And it equals negative 1. So 3 minus 1, that's 2. So this we're looking at y plus 2 equals negative 1. We'll subtract a 2 to both sides. So we've got y equaling a negative 3. Now, just so you know, a lot of times you see this answer written as an ordered triple. So our ordered triple, we're going to see this with the x value of 3, the y value as negative 3, and then the z value as 1. And that's it. That's all she wrote. I hope this made sense to you, and I'll see you next time.